In the workbench window, we can drag and drop steady state thermal into the project schematic. We shall share the common geometry here. And from CFX output, we can drag and drop into steady state thermal setup. So that is, the temperature data from CFD output will be mapped onto thermal model. Okay, let us edit the mesh in both cases. In the CFD domain, we shall suppress the solid body and go ahead with the fluid domain alone. Similarly, in the thermal model, we will suppress the fluid body and go ahead with solid model. Okay, let us right click and edit the cell A3, which is the fluid flow domain. The mesh for the fluid domain is open. We can expand the geometry. We can suppress the solid domain here. Right click, suppress body. We can rename this as fluid. Okay. Here in the named selections, we shall delete the faces which corresponds to solid domain. Right click, delete. We shall retain only the fluid domain regions: cold inlet, hot inlet, outlet, and fluid wall. So the temperature on this surface will be mapped onto the solid domain. Okay, the mesh is ready anyway. We can minimize and go back to workbench. Right click mesh, update. Let us double click CFD setup and edit the existing case. The preprocessor is open. There are some errors because some domains are missing in this case. So we shall delete the unnecessary domains and interfaces. Right click pipe, delete. Similarly, delete the interface. Now there is only one domain in this model. This is the cold inlet, hot inlet, outlet, and this is the wall domain. So we can rename this as fluid interface or fluid wall, because we are not giving any interface condition here. Double click here. So this will be wall boundary. The temperature whatever we get on the fluid wall will be mapped into the solid domain. Okay, we can close this and start the analysis for the CFD part. Double click solution and start the solver. We shall retain the same settings in solver manager, but go to initial values. Here in the initialization option, by default it is initial conditions. You can change it to automatic. It means if there are any results available already, it will start the analysis from that point onwards, so that the convergence will happen quickly. Now we can start run. The solver has started. Here we can see it is starting from the previous results onwards. So it has started from iteration number 200. And here you can see the iteration number. This first part represents the iteration number of the previous case, and this one represents the iteration number of the current case. Okay, we can check the user points. It is almost same. There is no variation in the convergence, as well as there is no variation in the outlet temperature. So we can stop the simulation. You can stop by pressing this button. Click OK. The solver is finished. You can click OK. Minimize solver manager and go to workbench. We can refresh the results. Right click, refresh. We shall go to CFD post processor and check the temperature on the fluid interface. The plots are retained. We shall check the temperature profile on the outer boundary. Select fluid wall, double click, change the variable to temperature, hide this plain one, apply. So this is the temperature on the wall boundary, that is on the outer wall of the fluid domain. This data will be transferred to steady state thermal model. Okay, let us minimize this and go to workbench. The first part is ready now. You have solved the CFD analysis and got the temperature distribution. Next we shall edit the steady state thermal and map the temperature data onto the solid domain. Okay.